Question number 8 from NEST 2007. This question is from trigonometry. The value of the expression s, which is cos of 2 pi by 7 plus cos of 4 pi by 7 plus cos of 6 pi by 7 is negative 1 upon 2, negative 3 upon 7, negative 4 upon 7 and 0. To solve this particular equation or to solve the question, we are going to take the help of complex numbers. Okay. Let us suppose that we have a 7th degree equation like this. Z raised to 7 minus 1 equal to 0. Okay. And we know how to solve this equation, right? We say Z raised to 7 is 1. We will write it as e raised to I 2 pi. But we know that this being a 7th degree equation or polynomial, right? It should have 7 roots in C. Okay, it should have 7 roots in the set of complex numbers, right? But like we do it for the complex cube roots of unity, we usually take it as omega. Let's take z this time. Okay, so what do? We modify this. We say therefore z will be equal to e raised to I 2 pi by 7, and if you remember, we actually add n here. Okay, and then we say n can either be 0, 1, 2 until 6, right? That's because of the periodicity of 2 pi trigonometric functions after 2 pi. Okay. Acha. Now let us also consider the factorization of this. Okay, what will be the factorization of z raised to 7 minus 1? Okay, it will be z minus 1 into 1 plus z squared plus z cubed plus z raised to 4 plus z raised to 5 plus z raised to 6. Okay, now if you do not know this formula, you can also arrive at the same by considering the sum of first n terms of a GP. Okay, sum of first n terms of a GP. So in this particular case, the first term is 1. Okay, first term is 1, and you need to find the sum of first 7 terms. Okay, sum of first 7 terms, and the common difference is common ratio, sorry, is z. R is z, and then you know that this particular expression here is actually the sum of first 7 terms, right? And that is actually the formula. You people might be knowing that, right? It is a into r raised to n minus 1 upon r minus 1, or other way you can do it. Okay. Okay, now what I'm going to do is I'm going to write or take z as e raised to I 2 pi by 7. Let us select this particular 7th root of 1. Okay, you can also take any other root, but I'm choosing n as 1. Okay, I'm choosing n as 1, so z is equal to e raised to I 2 pi by 7. Acha. Now why are we doing this? Okay, look, if we put z equal to e raised to I 2 pi by 7 in LHS, okay, in LHS we are going to get 0 because it is a root. On right side, definitely this is not equal to 1. Okay, this is not equal to 1, which means z minus 1 will not give us 0, but what will give us 0 is the green expression. Okay, so we can say substituting or putting in above equation, okay, putting in above equation we get. So on LHS we are going to get 0 because it is actually the 7th root, equal to. Now z minus 1 is a non-zero complex number, okay, because it is not equal to 0, right, into 1 plus whatever thing we will get, and it's equal to 0. Now if the non-zero complex number is there as the first factor, then the second factor must be 0. Okay, this part must be equal to 0. Okay, now if it is equal to 0, I must say that its real part should be equal to 0. And of course its imaginary part will be 0, but as of now, because we have cosines here, the real part should be enough. Okay. Okay, now there is one more thing that we need to use, and that is de Moivre's theorem. It says that cos theta plus I sin theta raised to n, okay, is cos n theta plus I into sin n theta, right? Now if you know this, then the solution will be a lot easier, right? Because look, if I go for e raised to I 2 pi by 7, then basically I'm having cos of 2 pi by 7 plus I into sine of 2 pi by 7, and this is raised to n. So I will basically get cos of 2n pi by 7 plus I into sine of 2n pi by 7. Okay, now this is required because now we have successfully managed to separate the real and the imaginary parts of cos 2 pi by 7 plus I sine 2 pi by 7 raised to n. And how is it going to be useful now? Let us come to this expression here. Okay, let me now use red color for that. Okay, so what is that expression? Let's write it. Therefore, real part of 1 plus z plus z squared plus z cubed plus z raised to 4 plus z raised to 5 plus z raised to 6, that will be equal to, of course I need to take one, for z I need to take cos 2 pi by 7. Now for z equal to 2, this will be cos of 4 pi by 7. Mind you, we are only considering the real parts, okay? For z cube it will be how much? Cos of 3 into 2 pi by 7, so 6 pi by 7. For z raised to 4 it will be cos of 8 pi by 7. For z raised to 5 it will be cos of 10 pi by 7. And for z raised to 6 it will be cos of 12 pi by 7, and all of this is equal to 0, right? The total sum, okay? Because real part is 0, right? Because real part is 0. Now how is this going to help us? Okay, there is another formula from trigonometry that we are going to use. That formula is cos of 2 pi minus theta is cos theta. Okay, now look, this gives us cos of 2 pi by 7 equal to cos of 2 pi minus 2 pi by 7, right? 2 pi minus 2 pi by 7, and that happens to be cos of 12 pi by 7, correct? Similarly, so this has become equal to the last one, okay? And similarly I can say that cos of 4 pi by 7 will be equal to cos of 10 pi by 7, and cos of 6 pi by 7 will be equal to cos of 8 pi by 7 by using the identity that we have used here. Cos of 2 pi minus theta is equal to cos theta. Now if you consider the first three terms here, that is s. Okay, what is s? If you consider the first three terms there, is it not actually equal to s? Cos of 2 pi by 7 is there, it is here. Cos of 4 pi by 7 is there, yes it is here. Cos of 6 pi by 7 is there, yes it is here. Which means we now have 1 plus s again equal to 0, 2s equals 1, so s will be negative 1 upon 2. S will be negative 1 upon 2, and hence it is option A. Okay.